Hello learners and welcome to your natural sciences lesson. So today we're going to be discussing electric cells. But first, before we start, did you know that an electric cell is a device which converts chemical energy into electrical energy? So a cell converts chemical energy into electrical energy. So in this lesson, we're going to be looking at what a cell is, where do we find a cell, and what are the uses of an electrical cell. Now, before we get to that point, there are certain goals that we need to make so that we can be able to achieve them by the end of the lesson. So by the end of the lesson, I want you to be able to explain that a cell is a system in which certain chemical reactions can cause the flow of electricity through an external circuit. And also, I want you to be able to identify cells as a source of electricity, and then lastly, be able to describe a battery as a group of connected cells. So these are the goals that I want us to achieve by the end of the lesson. But then for us to be able to do that, we need to take the main idea, being the electric cells, and then divide it into two components, whereby we're going to be looking at a cell as a chemical system, and then also look at a cell as a source of electricity, and then again the cell or the battery as a group of cells. So you're going to take the main idea, divide it into two, starting with the main concept, being the cell as a chemical system, and then after going to the cell as a source of electricity, and then looking at a battery as a group of cells. Then, these are the things that you already know about electricity and cells in general. So we already know that electric circuits are a path for transmitting electric current. We already know that electric circuits can be connected in either series or parallel. And then we already know that electric current in series remains the same at every point. So at whichever point we're measuring the electric current, if that electric circuit is connected in series, at whichever point we're measuring the current, it is going to always remain the same. And then we also know that electric current in parallel divides. So current in parallel, it divides according to the resistance of the resistor. So now that means in any parallel circuit, the higher the resistance that we have, the lower the current that you're going to have. So in other words, when the current increases, the resistance is going to decrease. Or if we have a higher resistance, the current passing through that resistor is going to be small, because of the relationship that they have between them. Now, with what we know, can we then be able to answer this question that is asking us to draw an electric circuit? And in this electric circuit, we need to have 3 resistors, and they must be connected in series. We also need to have a battery, and this battery needs to contain 5 cells. And then we also need to have a closed switch. So, our electric circuit must have 5 cells. Remember, we have a positive terminal and a negative terminal. Together they make up a cell, but then should I have another cell, that's now going to be a battery. So we need to have 5 cells. This is 1, this is going to be 2, 3, 4, and 5. So we have 1, 2, 3, 4, and 5. All of these cells connected together gives us a battery, and this battery contains 5 cells. Now, the cells are done. We now need to have 3 resistors that are connected in series. Remember, we are saying that if resistors are connected in series, the current that we're measuring at any point is going to be the same throughout. So the current measured at any point is going to be the same as the total current of the entire circuit. So I have my resistor number 1, resistor number 2, and resistor number 3. So we can label them. And if you want to, we can label them as R1, R2, and then R3 to denote the number of resistors that we have. Now, we also need to have a closed switch. So the resistors that we are asked to draw, we have drawn them, 3 of them. And then the battery that needs to contain 5 cells is drawn. And then the last thing to draw now is our closed switch. So for our closed switch, we can just put it on the side. Remember, to show that it's a closed switch, you can just put 2 dots on this conducting wires that we have there. So Remember, we are saying that in series, the current is going to remain the same at whichever point you're measuring it from. If you're measuring the current across the resistor number 1, that current across resistor number 1 is going to be the same as the current if you were to measure it again at resistor number 2 and also resistor number 3, or at any given point that you are having there in a series connected circuit. The current is going to remain the same. So if we had an open switch, now if we had an open switch, the difference between the open switch and the closed switch would be the following. The two connecting wires would not be in contact, they would not be connecting together, so that would mean there won't be any current flow. So if the switch is open, there's no current flow, but because our switch is closed, there is going to be a current flow. So therefore, our switch is closed, and we're going to have a current flow with all the ratings that we are given here. Now, with that said, now we can move on to the words that you're going to be using throughout this lesson. So to better explain the main idea being the electric cells, we're going to be using words such as a battery, electric cell, electrolyte, and electrode. So these are the words that you're going to be using in better explaining the main concept being the electric cells, and this is just going to better to make you better understand when we are talking about, or what we are referring to when we're talking about an electrolyte, an electrode, and all of these other words that I mentioned here. So before we start with the first concept, we're just going to quickly go for a short break, and I will see you just after this.